Let us try to understand the concept of prime implicant and essential prime implicants. To have a good understanding on the concept of PI and EPI, you should have good grip on how to do the grouping in a Q-map. If you observe the previous year GIT questions, there are a good number of questions from these particular concepts. Okay, and this is a bit tricky to understand, but once you understand how is it happening, so there won't be any confusion, right? So listen carefully. Let me first read out the definitions. Then, by taking examples, we'll be learning how to utilize these concepts. So prime applicants, these are maximum possible grouping in a K-map. While obtaining PI, the redundant group should be included such that a smaller group must not be completely inside a larger group. So what is the meaning of this one is, suppose students, for example, this is a map given and they ask us, so obtain the number of prime implicants and obtain the number of essential implicants. So what we'll be doing is, so you do the grouping. So for example, if I ask you to solve this K map, you obtain the minimized expression from this K map. So you will be doing a grouping like this and you will be doing a grouping like this. So you'll be stopping here. But while dealing with this concept of PI, EPI, etc., so what you have to do is you have to see, so although all the min terms are covered, is there any further grouping possible or not? So you need to see that. But you should do that grouping in such a way that that group should not be completely inside a bigger group. For example, you may say, sir, I can take a pair like, I can take a single element like this. If you take like this, so this is completely inside a bigger group. So that is not valid. But there is absolutely no problem if I take a group like this. If I take a group like this, you see, this group is not completely inside a bigger group. So that's all. I can't do any further grouping. So how many grouping you have done? 3 grouping you have done. So number of PI in this case is 3. Number of PI is 3. So that is what the point is. These are maximum possible grouping in a K-map. So you cannot do any grouping beyond this. So number of PI is 3. And if they ask you the expression, again by writing ABC pattern, so you know how to write the expression for each group. So you can write the corresponding expression. So they may ask, what are the PI, what are the EPI, like that. So you have to identify which group is PI, which group is EPI. Then you can write its corresponding notation. You learn this, by taking many examples in the previous videos. Okay. So here you see, while obtaining PI, redundant groups should be included. See, this is a redundant group. This was actually, we will not be doing this group if we are obtaining the minimized expression. So redundant group should be included, such that a smaller group must not be completely inside a larger group. Okay, as I said, you cannot have a grouping like this. All right. So let us try to find PI in all these maps. So let's say here, so I'll be doing a grouping like this. I'll be doing a grouping like this. I'll be doing a grouping like this. So I'll be stopping here if I am interested to do the minimization. But here, any other group is possible or not, you have to see. So yes, I can have a group like this. This is a redundant group. So here also, let me do in a color map. So this is a redundant group. This one is a redundant group. Okay. So how many group we have done, including redundant group? So 1, 2, 3, 4. So number of PI answer is 4 for this. What about this group? I mean the next map. So you see how many group you can do. 1, 2. So I think you'll be stopping here. I mean this one, and you can have this one. So I think you'll be stopping here if you are doing the minimization, because all the min terms are covered. So now what are the other possibility means? So this is a redundant group I can make again. So in this case, how many group you have done? You have done 4 group, right? So 4. Similarly, let us do here. In this case, how many grouping you can do? So this is one group. This is one more group, 2. This is one more group. So if the question would have been to ask, like to how many or what is the minimized expression, I would have stopped here. But while finding PI, you again check what are the other possibilities. Even though it is not, you need to check. So I can clearly see This is one possibility. So this is not inside a completely, it is not inside completely a bigger group, right? Even I can do this one. This is also possible. This is also possible. And even this is also possible. Yes or no? This is also possible. So the pink color, groupings, these are the redundant groups. So in the minimization, we will definitely not include this, but while finding, you have to include this. So number of PI in this case is, how many grouping you have done? 6. 3 in green color and 3 in pink color. In the next one, if you see here, so you see here, I cannot find any quad, I cannot find any pair, all these will be single. So all these will be single. In this diagonal pattern, all are single. So how many grouping you have done? 4 grouping you have done. So number of PI is 4. You can't have anything else, right? You cannot do any other grouping here. What about here? So obviously you can do a grouping like this. You can do a grouping like this. Is there anything else possible? Some of you may say, sir, we will be doing a grouping like this. If you do like this, so you see that this small group is completely inside a bigger group. That you are supposed to avoid. You cannot do a grouping something like this. So you have to make sure that group should not be completely inside a bigger group. So is there any grouping possible? No, not possible. So how many group you have done? 2. So answer is 2. Similarly, in this case, so this is one group possible. I think this case I have already taken, right? Yeah, this case I have already taken. So no point to take this. Okay. So this is what your PI. So how to find PI we understood. Now students, let us try to identify what is EPI, essential prime implicants. So EPI are those PI which contains at least one mean term exclusively. What is the meaning of this statement is? So remember, like, so all the grouping you have done. So let's say this map, if I'm checking, this map I'm checking. So if somebody asks me how many EPI are there, so I'll check each PI. So here there are 3 PI. I'll check each PI. What you will be checking? We'll be checking that. Let's say I'm checking this particular PI. I'll be checking, is it containing at least one mean term which is not covered by multiple groups. So this group, if you observe, it is containing 2 mean terms, this and this. This one is covered by multiple group, but this is not covered by multiple group. So yes, this group is containing one mean term exclusively. That means this one is not part of any other group. So yes, so let me put a tick mark. So this is a EPI. In the same arguments, is it a EPI? Is it a EPI? How do you know? So again, out of 2 ones, so this is shared by multiple group, this is not shared by multiple group. So yes, so this is also containing one mean term which is not covered by multiple group. So this is a EPI. And what about the pink one? So if you see this pink one, so this is a redundant group. So here you see both of these are covered by multiple groups. So this one is covered by 2 groups, and even this one is covered by 2 groups. So this is not containing at least one mean term which is not covered by multiple group. Right? It is not containing at least a mean term which is covered by multiple. So you have the condition that it should be exclusive. That means it should not be part of multiple group. So it is not happening. So I am putting a cross here. So this pink one is not EPI. So the answer of EPI is 2. So EPI is a PI which contains at least one mean term exclusively. So you have to check each group and you need to see whether it is it containing at least one mean term which is not covered by multiple group. That is the criteria. If you observe, so this is API, this is API. You can directly see, students, there should not be multiple markings. Like here you see this one is multiple marking, I mean covered by multiple group. So this one is not covered by multiple group, this one is not covered by multiple group. So yes, these are API. This is not API because both of the mean terms are covered by multiple groups. Even same is the story with this also. So here also your API is 2. What about this? So this is API, this is API. That's all. So this is not a API, and even this is not API because these ones are covered by multiple group. Even these ones are covered by multiple group. So this is not API because both mean terms are covered by multiple group. This is also not API because covered by multiple group. So here I am putting a cross. This is not API. This is not API. So here this is not EPI and this means no. So here the answer is again 2. What about here? So here you see, students, so any group you take, so it is not coming the criteria of EPI, you see. So this one if you see, so it's containing 2 mean terms and both mean terms are covered by multiple group. So this is not a EPI. And if I am observing this green line, if I am observing this one, so both of these mean terms are covered by multiple groups. So this is also not API. And even same is the story with this one also. So if you see, both of the mean terms in this group are covered by multiple group. And same is the story with this one also, because again these two are covered by multiple group, and this is also not EPI. And even this side one, so this one, so this one are covered by multiple group. So this is also not a EPI. So the number of EPI in this case is 0. So there are 6 PI and we have checked each PI. So none of them is satisfying this criteria. Then what is this? So in this case, you see there are 4 groups. So each of these are not covered by multiple group. That means, so this is not covered by multiple group. This is not covered by multiple group. This is not covered. This is also not covered by multiple groups. So here, can I say each group is API? Yes. So each of them are API. Now in this case, if I ask you what is the answer, so is it a API? Yes, because this one is not covered by multiple group. So this is a API. So what about this group? Is it API? Yes, this is also API, because here 3 mean terms are not covered by multiple group. So here also the answer is 2. Many students, they say the answer is 3 plus 1 4. So they count this is 1 and they count 3 here. So you are not supposed to count this group as 3. Why? Because you are checking whether this particular group is satisfying the criteria of EPI or not. In all the previous examples, so by coincidence you can say that in every case, let's say this one, so only 1 mean term, it is not covered by multiple group. But here the difference is, instead of 1 mean terms, 3 mean terms are not covered by multiple group. But you are not supposed to count it as 3. We are not saying that number of mean terms which is not covered by multiple group is EPI. We are not saying that. You need to observe the overall group. You have to see, is it containing at least 1 mean term which is not covered by multiple group? Yes. So this is containing 3 mean terms which are not covered by multiple group, but that doesn't mean that we will be counting it as 3. So this overall group is a 1 EPI. So answer is 2. So we have obtained the EPI and PI for all these cases. And you can see this example also. So this is, I have taken like this. So let us calculate number of PI and EPI. So how many PI? So it is equivalent to how many group you have done. So one group is, students, you can see one group is the diagonal pattern. I mean this and this diagonal pattern. And one is this one. I mean this one. And one is this one. So this is also a PI and this is also PI. So basically how many group it is done? 1, 2, 3, 4. So number of PI is 4. What about number of EPI? So again we need to check. So is it a EPI? Yes. Because you see this one is not covered by multiple group. And even this one is not covered by multiple group. So this is containing 4 mean terms. Out of 4, 2 are covered by multiple group, but 2 are not covered by multiple group. My requirement is it should have at least 1 mean term. So here I have 2 mean terms are there. So no doubt this is a API. Same is the story with this group also. So this one is not covered by multiple group. Same is story with this vertical one also, because this one and this one are not covered by multiple group. And same is story with this diagonal one also, because out of 4 this is covered by multiple groups, but these 3 are not covered by multiple groups. So here EPI is also 4. So I believe after going through around 7 to 8 questions, whatever I have taken, so you don't have any confusion regarding how to find EPIs. How to find EPI. Here one observation I would like to give you, friends. The observation is, so whenever you are finding the minimized expression, okay, so you need to think yourself. I'm asking the question, you pause the video, you think yourself. Whenever you are finding the minimized expression, what do you think? So that expression will contain all EPI or it may or may not contain. So definitely that minimized expression will contain all EPI. Why? because we are saying EPI is that group which is containing at least one min term which is not covered by any other group. So that means if you are leaving EPI, so that min term cannot be covered. That means, let's say here, if I ask you, so you cannot, minimize expression, you cannot, escape this particular group, because if you omit this particular group, so this min term will be uncovered. It cannot be coming under the group. So you cannot omit any EPI. So the minimized expression will definitely contain all EPI. EPI are unavoidable. You cannot escape the EPI, because if you are missing any EPI, it means you are missing some min terms or some max terms. So you cannot do that. So what I can say, the minimized expression contains all EPI. The minimized expression contains all EPI. And what is the meaning of this optional PI? For example, students, you see. So let me say this is group 1, this is group 2, this one is group 3, and this one is group 4. So if I ask you, so what is the minimized expression this will contain? So definitely group 1 and group 2 you cannot avoid. These are the EPI. Then one possibility you can take is along with group 1 and group 2. If you take group 1 and group 2, so these are covered, but this one is not covered in group 1 and 2. So to cover this one, you have two options. Either you can take this, or even you can take this. So you can take 1, 2, 3 like this, or you can take 1, 2, and 4. So that means I can say overally it will contain 1, 2, and 3 or 4. 3 or 4. So the minimized expression contains all EPI and optional PI. It is not necessary that it will cover all PIs, optional PI. I can take either 1 to 3 or 1 to 4. So that is what the meaning is. The minimized expression contains all EPI and optional PI. So here minimized expression will contain all the EPIs. In this case also I can say it will contain all EPIs. And when I say all EPI, but in this case you see all EPI are PI itself, or all PI are EPI. All PI are EPI in this case. That's why, so like if I am considering all EPI, it is being covered up. I don't have to think of any other thing, because already PI is 2 and you are taking all 2 are the EPI. Then there is no other possibility. Okay. Then what about in this case, friends? This case, so this one and this one it will definitely contain, and again the same story like this. So here this and this it will be definitely you have to take this and this, these two EPI, and then to cover this one, so you have again two options. Either you can take this or you can take this. So again it is containing all EPI and optional PI. In this case you see that here if I am considering only EPI, so my job is over. So the minimized expression here is containing only EPI. Only EPI, because if all EPI if I am considering, then all the min terms are covered. So I don't have to take any PI here. So I don't have to take any PI. In this case, in this one if you observe, I am taking EPI, I am also taking PIs. So these are EPI and one PI I have to take. In this case, if I ask you what is happening in this case, again you have to take EPI along with PI. In this case, if you are taking only EPI, the job is over. In this case, only EPI, job is over. But in this case, what you have to do, students, you have to take only P, because there is no EPI. So you may have situation where there is no EPI. So in this case, you have to see the PIs, that the minimal set of PI, so that all the min terms will be covered. So you don't have to take all these 6 PI, right? So even this green color line, if you see, if I am taking these 3 groups, all the min terms are covered. Yes or no? So the minimized expression will contain the 3 green groups. So number of PI is 6. That means in this case I can say that it contains optional PIs. So optional PIs. There are no EPIs. So I hope you understood what is the meaning of this. The minimized expression contains all EPI and optional PI. Now can you think yourself, students? So in the previous video we have seen in one question that the K-map provides the minimized expression, but that expression is not necessarily to be unique. So what is the sufficient condition when somebody can say that the K-map expression is unique, when you can guarantee that the K-map expression is unique? So that is possible if all PI are EPI. if all PI are EPI, like this case, when all PI are EPI, like this case, where all PI are EPI, in this case, so you don't have any other option to go beyond EPIs. So I can ensure that in a particular K-map, if all PI are EPI, then K-map will definitely give you a unique expression. In a K-map, if all PI are EPI, then minimized expression is unique. So we understood this point, we understood this point, we understood this point, and here students, this point in an n variable K-map, at maximum we can have 2 raised to power n minus 1 number of EPI possible. Okay. So this is what the example is. So in this map you see that here it's a 3 variable K-map. So 2 raised to power 3 minus 1, that is 2 raised to power 2. You have 4 number of EPI. You cannot find any other combination where number of EPI will exceed 4. There is other way to prove this also, but from this example you can understand. In any particular K-map, if I am selecting the groups in a diagonal pattern, you will have the maximum number of grouping and all the grouping will EPI. And when you are selecting the diagonal pattern, always you are covering half of the cell. So then it is 2 to the power n number of total cell, half of this will be 2 raised to power n by 2, which is 2 raised to power n minus 1. So in a K-map, we can have at max 2 raised to power n minus 1 number of EPIs. Okay. So where this concept of PI and EPI are used. So you know students, while learning the minimization of expression using K-map. So I just said, you do the grouping by giving clarity, octet, quad, pair, single like this. Yes or no? But otherwise, so if you are not following that approach, so you can go through this algorithm. So to obtain the minimized expression, so I can say that the step 1 will be find all EPI and PI. Next, select all EPI. 3. In addition to EPI, select PI, select minimum number of PI, select minimum number of PI, so that all mean terms are grouped. So this is what is the algorithm for minimization of K-map using the concept of EPI and PI. Okay. So this is where it is used. If you refer some foreign standard books, so you'll find these all statements, but in Indian author books, so simply the concepts are explained, but why it is used or what is necessary of these all things are not given. So to use this particular algorithm, so we make use of this concept of PI and EPI. So this is what all about your K-map students.